Hello everyone. In this video we are going to discuss that when a charged particle moves in a perpendicular magnetic and electric field together at the same time, such that the electric field and magnetic field are perpendicular to each other and also perpendicular to the velocity of the charged particles, and they are set in such a way that the force due to the electric field and the force due to the magnetic field, they act in the opposite direction. And if we have a bunch of charged particles having different velocities, then from that bunch of particles we can choose out a particular particle having a specific velocity. So by using the perpendicular electric and magnetic field and allowing a charged particle to move through that magnetic field at an angle of 90 degree to both the electric and the magnetic field, we can choose some of the particles, a specific particle having specific velocity, and this is known as velocity selector or velocity filter. So let us see how it works and what is the basic concept behind this. We are going to discuss the motion of the charged particle in the perpendicular magnetic and electric field, where magnetic and electric field are also perpendicular to each other. Let us see the diagram here. Look at the region here. This region we have both electric as well as magnetic field. Magnetic field is in the inward direction, which is given by the cross sign here. Whereas two plates are there, one positively charged and another here it is negatively charged, and the electric field exists between the positive charge and the negatively charged plate, and you know the direction is always from the positive to the negative charge. Now these are the two slits, S1 and S2. Slit means the opening through which the charged particles can enter. Now when the charged particle enters here, then these slit S1 and S2 are in the same level. So we will find that a specific charged particle having a specific velocity will be undeflected by the electric and the magnetic field, and it will come out straight and pass through the slit S2. Whereas the other particles having different velocities will have the deviation and they will not pass through S2. So through S2 only a specific charged particle having a specific velocity will come out. All the charged particle which enters through here has a different velocity, but one having the specific velocity will come out through it, and that's why it is known as velocity selector or velocity filter. Now let us understand how it works, and for example let us take some electrons having different velocities, and let us allow all of them to enter horizontally through the slit S1. Now when the electron reaches here, it encounters two fields. One is the electric field and another is the magnetic field. Electric field is from the positive to the negative plate, that is electric field is in this direction. So if the electric field is in this direction, electron is negatively charged, so the negatively charged particle will experience a force opposite to that of the applied electric field, and that's why the electrons will try to deviate itself in this direction. Okay, so this is all about electric field, and the electrons will try to move towards the positive plate, so they will deviate towards the positive plate. Now we have magnetic field also in the inward direction, inward to the plane of the paper. Now if the electrons which are negatively charged, we know that the formula for the force experienced by a charged particle is Q V cross B. So V cross V, the direction of V cross V, if you consider it to be in the inward direction magnetic field, and velocity is towards the right hand side, so in that case as it is moving in this direction, velocity is towards the right hand side, and in the inward direction the magnetic field, which is given by the cross sign, then we can use the right hand thumb rule or right hand screw rule to find the direction of the force experienced by the charged particle. Since the electron is negative, so the direction of the force on the electron will be in the downward direction, that is opposite to in which the electrons are acted upon by a force due to the electric field, which was in the upward direction. So now the electron will try to deviate in this path because of the magnetic field. Because of the electric field, it was deviated on the upward direction, and because of the magnetic field, it was deviated in the downward direction. So I hope it is clear to you. So now this is velocity selector. Here means we will have the forces due to the electric field and magnetic field in such a way that they equals each other, and if they equal each other, then that particle, that charged particle, will move in a straight line without any deflection. Otherwise, if electric field and magnetic field are, the force due to the electric and magnetic field are not equal, then the charged particle will not move in the straight line. They will get deviated in either of the direction, either in the upward direction or in the downward direction. So now let us see that in such a condition where the electrons having a specific velocity reaches the other end, the electric field will be given by Q into E. The force experienced by the electric field will be given by Q into E. Q can be written as E minus E, and the force experienced by the charged particle due to the magnetic field, perpendicular magnetic field, Q VB sine 90, that is QVB, and the value of Q is minus E. So for a charged particle to move without any deviation, for an electron to move without any deviation, these two forces should be equal, that is EE should be equal to EVB. This is the force due to the electric field and this is the force due to the magnetic field. Now we are considering these two forces to be equal for a particular velocity of that electron, which will move in a straight line and come out of the slit S2, entering the slit S1 horizontally, and it will come out of the slit S2. The velocity which is required will be, you can see here, E and E will cancel out, so the value of velocity will be electric field strength divided by the magnetic field strength. Now see, if the electrons, there are many electrons having different velocities, and you need to find out, or you need to take out a particular electron which has a certain velocity. So then you need to take the value of E and B, that is the electric field strength and magnetic field strength, in such a way that their ratio equals to the is equal to the velocity which needs to come out of the slit S2. Okay, so because of this, in such a condition, a particular electron having a particular velocity will be obtained through the slit S2, and this arrangement is known as velocity selector or velocity filter. The arrangement can be used to select charged particle of particular velocity out of a beam in which the particles are moving with different speeds. This arrangement is called velocity selector or velocity filter, and this method was actually used by J.J. Thomson also to find the charge to mass ratio, E by M, for an electron. So I hope this is very clear to you, but still then if you have any doubt, you can inform me and accordingly I will give you the solutions. Thank you.